Thank you, Webmaster, for the today, Sakshi Priyam. And I really greet the Honorable Speaker for today, for this virtual boot camp which is being organized. Sir, we on behalf of the management as well as IEEE Student Branch and the faculty of BBD and ITM, I really welcome you for this. And I also congratulate the way this whole team, under the leadership of Mr. Srikanth, who is the chairperson of this student branch, is doing it. And I really greet the organizing secretary, Dr. Khadim, as well as branch counselor of BBD ITM, Professor Rafiq Ahmed, for doing it so gracefully and in a dignified way. So I wish you all the best for this session also, dear students. And I'm sure this will be quite enriching session today, as the profile of the Honorable Speaker is inspirational, and I'm sure the purpose will be fulfilled. So over to the anchor with all the best wishes. Thank you very much.
Thank you, sir, for your inspiring words. Now I think we can more energetically start this boot camp. So today, as we have an interactive webinar on some technical issues by one of the most eminent Professor, Dr. S. Chatterjee. So we all welcome you. Sir has been awarded PhD degree in electrical engineering from Punjab University, Chandigarh. He has obtained BE in electrical engineering from MACT Bhopal. Professor Chatterjee has obtained ME in electrical engineering from eminent Allahabad. He is a member of IEEE USA, life member ISTE India, fellow IE India, and also life member NITTTR and Alumni Association. Professor Chatterjee has supervised 16 PhD theses and 115 ME theses. He has written 2 textbooks in electrical engineering and has more than 200 publications in various international and national journals to his credits. He has won the Best Paper Award in IE India Journal. It is our opportune moment to have you here, sir. Now I would hand over to our Professor Dr. S. Chatterjee. Sir, the stage is all yours.
Thank you. Thank you very much. At the outset, I would like to definitely thank the organizing committee, Dr. Chauhan, the director of BBDM, and all the members who are directly or indirectly connected with this event. Especially, I would like to thank Dr. Khadim, whom I know for about last 3 years. He has worked with me in an institute in Hoshiarpur, Punjab, and there I have seen him. He has a lot of potential and is a very honest and sincere worker, and especially he has the potential of doing research. So he's a very research-minded person, and I always wish him the best so that he can do a lot of more things for this institute. I'm equally thankful to the organizing secretary, the convener, the director, and everyone who's directly or indirectly connected with this event, this mega event, I would say, and giving me an opportunity to be among with you for this session. So I was just thinking, what should I speak during this technical session? So one thing comes to my mind, and that is of sheer importance these days, and that is automation. I was just thinking that let me share some of my experiences with this group, the young group, and I say the buzzwords and recent trends in automation. Next, please. Next slide. Yeah. The contents of this talk will be introduction, the analog versus digital instrumentation, wireless instrumentation, industry 4 scenario, because we are now living these days in the industry 4 scenario, intelligent public smart instrumentation schemes, IoT and its applications, cloud and grid computing. Next, please. So the basic thing which comes to my mind, to any engineer, to any scientist, is the word control. Now the question is, why control? Why is it required? Control, what is control and why is it required? What is its relevance? So given a system, you know that by default, if you feed some input to a system, you will definitely get some output, which is that by default. So, but that output has a question mark. The output may be of some relevance, may not be of any relevance, maybe a little relevance. So it is always the user who wants to use that output out of that system for doing some further work, to feed it some other system, for getting some other work, for getting some other things obtained, etc., etc. So that kind of output, which is relevant, which is useful, is known as desired output. So the system which only has the input, the process, and the output is known as an open loop system, as you all know, because here there is no control over the output which is obtained at its output terminals. That means, in other words, we can say that this is not the controlled output. Now, if this output needs to be converted into a relevant nature or of a usefulness, then it has to be controlled. Some control has to be devised on it, and naturally, we have to have a feedback path which gives it to the closed loop control system. The feedback will definitely be obtained from the output itself, and it will be compared with a comparator with the input, and that compared input in the form of error will be fed to the system. The system may have some disturbance. The input, the open loop system may also have some disturbances outside, but that will take care by this control system itself. So when you get an output which is obtained now after feedback, may be of relevance to you. So that is why this control is very important, and the automation is followed by this control. Now, the control in earlier days used to be, first of all, it was a manual control. Then came the semi-automatic control. It's a mechanical type of control. We had wheels, we had clutches, we had all sorts of devices. And then later on, we came with the electrical or electromagnetic controllers, wherein the electrical energy was used and not much of mechanical controllers were used. In between, pneumatic control also came, and finally, electronic controllers were achieved. The electronic controllers will have electronic input, and naturally, that can be either an analog type of controller or it can be a digital controller. And nowadays, as you all know, it is the digital age, and the controller actually works on digital input. Next, please. So, when you see the instrumentation and control scheme, what is instrumentation? The control scheme is all right because you need some hardware to make the system, and then to get the feedback, etc. You have to connect certain connections you have to do, and which may require certain measuring instruments also, and that total system becomes an instrumentation scheme. And since it is the aim of this scheme is to control the input in the form of desired output, so we call it instrumentation and control schemes. So it could be further divided into two types. One is the analog type, the other one is the digital type. As I said, the analog will have only the hardwares, the connections will be there, and it will have input, analog input, and definitely the output will also be analog in nature. But nowadays, as I said, the control computers have come in a big way, and the controllers are all electronic in nature. So they will definitely need a digital input. That means in the input side, we will have a converter, say ADC, analog to digital converter. And when you get the input, analog input, you apply it to the ADC, you get the digital output, and that is given to the computer. It may be a microcontroller, it can be an FPGA, it can be a microprocessor, but in general we call it a computer. And that is when fed to the control computer, it will process that input, and after processing it, it will come out as a digital signal only. But the digital signal will not be of any help to the final control element. The final control element could be a valve, it could be a relay or certain thing which doesn't understand what is a digital signal. So it has to be further converted into analog signal, and naturally at the output side you will have a DAC, which is D to analog converter. So you have two converters, one at the input side, which is analog to digital converter, and the other one at the output side, which is digital to analog controller. This is to be used for the final control element to make any control in the system. Next, please. Next slide. Yeah. So we have analog systems in two types. One is the wired hardware system. The other is the wireless hardware system. Now you can see in the wired hardware system, there are a lot of wires, cables, jumpers, etc., which make it very complex in nature. The hardwares are there and they are connected to each other from the input side, also to the output side, with the help of a lot of connectors, a lot of wires, a lot of cables, etc., etc. So it becomes quite a complex system. And to match to on the other hand side, we have now wireless hardware system. The hardwares are there, but they are not wired. They are not connected to wires or cables or whatever it is. So we have here one example I have taken. The example is of can you enlarge the screen, please? Please enlarge the screen. Yeah. The example is I have taken from the London Heathrow Airport. We have taken three junctions. One is the London Heathrow Airport. The second one is the London Oxford Street, and it is a station. And the third station is again London Piccadilly Station. Now here you see the data is kept in the cloud server, or it can have a server or a cloud itself. And from that server, the data goes to all these things without any connection of wires or cables. Here you need certain loggers. The loggers the data can be accessed either by the browsers, by browsing it, or by mobile, tablets, etc., or by PC, or by Wi-Fi arrangement. And then it is given to the through logger, it is given to the different systems. Please enlarge the screen. Please enlarge the screen.
Sir.
Screen enlarge करो ना ये थोड़ा सा. मतलब ये हाँ ये slide को yes. Please keep the slide in between. हाँ slide इसको रखे रहिए please. So that way you can see in case of a wireless hardware system, the hardwares are there, but they are not wired. They are only connected to Ethernet and Ethernet and connections also, software. Next, please. Next slide. Next slide. Yeah. So if you go to the digital system, that was the analog system. Now, if you go to the digital system, it will also have hardware supported by backup software package. The devices used here are such as microprocessors, microcontrollers, FPGA, PLCs, PCs, etc. And we have wireless digital program systems. One slide is there which can give you some idea of what is a digital system. It has the hardware in terms of microprocessor, microcontrollers, etc. And it can be a PC also. It can be a supercomputer also. It can be a server also. But they are all there, and the wirelessly they are not connected by wires. So it is wireless digital program system. Next slide, please. Wireless devices are the devices which are used in wireless systems, are wireless sensors, the smart sensors, the wireless smart sensors, the wireless modules, etc. One example is given here. You can see that there are a number of sensors here, and one integral part is the battery, which gives the source, which is the source actually. It will give the supply, and it becomes one package. And such 5 packages have been shown on the right hand side of the slide. And from all these packages, the data will flow in to the server. to the computer where it is going to be processed, and from there the data logging and dissemination of the data will take place. So this is wireless device system where you have the hardwares, but it is not connected by wires or cables. It is all through software connections. Next, please. Now, if you compare a wired and a wireless system, what are the main points on which you compare them? One is the distance. The second is the complexity. The third is the flexibility. The fourth is the security. The fifth is the redundancy. The sixth is the power loss. The seventh is the cost. And eighth, not the least, is the maintenance. Now, if you compare a wired and a wireless system, you will automatically come to know that distance is very, very important. If you have a wired system, the distance become a problem and it is a limitation. You will have no problem, no limitation of a distance in case of a wireless system. Complexity. Complexity also because of jumble of wires, cables, etc. So the system which is wired will have a lot of complexity. It will be a very tedious system, and whenever you have to do some maintenance or whenever you have to do some fault finding, it becomes troubleshooting, etc. It becomes a problemless task. Flexibility, it is very, very important, and it is very clear that the wireless systems are much more flexible as compared to the wired systems. Security wise also, the wireless systems are more secured, more secured. Now, how do you say that more secure? Because the data loss will be very less in case of wireless system. Whenever you have wired systems, depending on the distance, the resistance of the wire comes into picture, and there will be data loss, the signal loss, etc., etc. So the security is much higher in case of wireless systems. Now, redundancy, of course, it is more redundant as compared to the other system. Power loss, as I already told you, that whenever there is a wire, it will have certain resistance, and depending on the length of the wire, the power loss will be more and more. I square R loss will take place, and that is almost nil in case of wireless. Of course, wireless systems may have certain signal problems, but that is in comparison to wired system, it is negligible. Cost-wise also, the wireless systems now have become cheaper as compared to the wired system. And maintenance is much easier, much easier in case of wireless systems as compared to the wired systems. Next, please. Yeah, so this is one wired instrumentation versus wireless instrumentation scheme. I have shown this scheme here. In case of the left-hand side is a wired instrumentation scheme, and the right-hand side, as very obvious from the diagram itself, is a wireless instrumentation scheme. The wired system clearly shows that you will require a lot of wires. The data has to be taken from the junctions, from the different ports to the field junction box through wires and through cables. So process area cable is there, field area cable is there, and home run cable is there. And depending on what kind of data you are taking and what kind of signal you are taking, the size of the cable will differ. So from there, it goes to the marshalling cabinet for the control purpose. From the marshalling cabinet, it goes to the DCS or the PLC. That is the part of the controller these days. As you all know, PLC and DCS are the main controllers in industries. So it will again have wires, and a lot of wires, thick wires and cables are used here, and the data will be taken from these wires. The signal will be taken from these wires to the DCS or the PLC. The PLC will further give it to the workstation where it is to be processed, and that is also through cables. So there are different cables here, different connectors here, and it becomes a very, I would say, complex system. It has a lot of losses. It is a very costly system as compared to the wireless instrumentation. On the other hand, the wireless instrumentation scheme, which has been shown at the right-hand side, will have only one data receiving module, one data transmission module. and that is two-way. In this case, it was one way. In this case, we have two-way communication. That means we can interchange the data receiving station module with the data transmission module. And in between, we have a data monitoring module. And of course, sensor has been shown here. So there is no connection through wire or cables. The data are communicated through Ethernet and through computation, etc. So that becomes a very, very simple system, a very comparatively a cheaper system, and very eventful and dependable system as compared to the wired instrumentation scheme. So nowadays, it is the day of wireless technology. These days we are talking of wireless technology, and the whole instrumentation has now changed into the form of wireless instrumentation, as I have given one example here. Next slide, please. Okay, so if you compare some of the popular wireless technologies, what are the wireless technologies you have? You have Wi-Fi technology, which is IEEE 802.111. Then Bluetooth you have Zigbee. These are the three wireless technologies through which the data or the signal transfers, communicates from one place to another. And the points at which the comparison is to be done are the data rate, the range, maximum number of nodes it can handle, power consumption, the cost, and the applications. So if you see the data rate, in case of Wi-Fi, it is 11 Mbps. In case of Bluetooth, it is 1 Mbps. Bluetooth is normally used for domestic purposes, as you use in your mobiles, speakers connection, etc., and small controls. So it is only 1 Mbps rate. And then Zigbee has got very high rate, which is 250 kbps. So range-wise, the Wi-Fi has got 100 meters range. The Bluetooth is a very small range, that is 30 meters. And Zigbee also had 30 to 100 meters range. Maximum nodes which can be handled. By Wi-Fi, you can handle 20 to 250. Bluetooth, you can handle only about 7 at a time. And Zigbee is enormous, 65,536 nodes can be handled at a time. Power consumption is high in case of Wi-Fi. It is medium in case of Bluetooth, and very low in case of Zigbee. Cost-wise, it is, you see that Wi-Fi is high, very high, Bluetooth is medium, and Zigbee is low. So among all these, I think Zigbee plays a very important role in controlling, and it has on all parameters, it proves to be the better. And application-wise, if you see, LAN connectivity is broadband internet access can be done in case of Wi-Fi, and in case of Bluetooth, you have wireless connectivity between devices such as phones, PDAs, laptops, etc. And in Zigbee, industrial control and monitoring, building automation, room control automation, etc. can be done. So normally the Zigbee IEEE 802.1.15.4 is normally used in case of industries. Next, please. Yeah. What are the advancements in wireless? Wireless is mobile is one of the biggest examples. You have wireless controller. You have mobile in your hand here, and you can use it for any place you feel like, and at the high speed also. So first generation was in 1980s, which has the 2.4 kbps rating, and it was known as first generation 1G. The second generation came in 1990s with a speed of 50 kbps. Third generation arrived in the year 1998 onwards. It has a speed of 2 Mbps. Fourth generation, 2008 onwards, has 4 Gbps speed. And fifth generation, which is now to be launched in 2020. In India, it has not been launched yet, but it is coming. I think your Jio has made a MOU with I think, which it has gone with an MOU of with some company, and it is going to launch it very soon, and it will be having 20 Gbps. Next, please. Next. Yeah. From Industry 1 towards Industry 4. How have we come from Industry 1 and now we are sitting at Industry 4? What are the progress? What are the changes taking place within these years? You see, the first Industry 1 came in about 1784 in the year. It was using more of mechanical energy, and steam engines were used. More of mechanical controllers were used, clutches were used, then wheels were used, gears were used. These were the controllers, and this was the status of the industry in the year 1784. Before that, it was all cottage industry. So before cottage industry, from cottage industry, when it came to industry 1, this was the scenario, and that was the year 1784. In the year 1870, there is a boom, there is a change, a lot of change, and we call it the industry 2 scenario. Here we see that electrical mass production was done, and a lot of other types of controllers were introduced, and that was 1870 onwards. A lot of semi-automatic controllers were introduced, and the industry was known as at the scenario 2 advanced industry state. The third scenario of industry 3, it arrived in the year 1989 onwards. And here you see a boom of automation, the computers and electronics. A lot of electronics was introduced, more automation was introduced, all sorts of automations were there, and computerization took place. So these robots, etc., they were introduced here slightly. And today, which is the industry 4 scenario, we have a lot of cyber physical systems, we have Internet of Things, and we have networks, and it is all, you can say, wireless technology these days. And that is the way of how the industries have progressed from cottage industry to industry 1, to industry 2, to industry 3, and industry 4. Right now, we are sitting today at the industry 4 scenario. Next slide, please. Again, industry 4 scenario. Industry 1 had what was in 18th century, as we have seen in the last slide also. 18th century was industry 1, which was using most of the steam power, right? And the second industry 2 that came in the 19th century, it was the mass production instead of mechanical production, moving away from, and the mass production took place, and assembly line also was introduced, and there semi-automatic controllers were used. In industry 3 situation, ICTs, electronics was used, automation came in big way, and network production started. That was the scenario of industry 3. And industry 4 scenario, which is the today's scenario, advanced robotics and 3D printing, Internet of Things, that is IoTs, artificial intelligence, big data, intelligent flexibility, and distributed data system, etc., have been introduced. And today we are sitting at the industry 4 scenario. Next, please. Here I have taken one example of intelligent / smart instrumentation scheme. One example is that is the electricity is generated, it is transmitted, it is distributed, and finally utilized. So adequate hardwares are to be used, and those hardwares, for running those hardwares, you need backup softwares and firmwares. So the generation could be either from solar, wind, etc., or it can be your conventional power generations, like such as power plants, hydropower plants, thermal power plants, nuclear, etc., etc. The power is transmitted, the transmission is there, and after that, long transmission lines, it is the distribution. Distribution is more important because the losses are more in distribution as compared to transmission. The distribution consumption will have the substations, and you'll have the control center also. So this maybe several substations are there depending on how much power is being distributed, and then it is sent to the control center. From there, we will further get it to the utilities sector, where it could be either residential in nature or commercial or industrial, etc., etc. So this is what is the intelligent smart instrumentation scheme now being done for generation, transmission, distribution, and utilization of electrical power. This is one example. Next, please. Next slide. Now, techniques used for intelligent systems. We call it intelligent systems because most of the systems are now using intelligent algorithms and artificial intelligence techniques. So that is why it is AI based techniques, machine learning techniques, and deep learning techniques. What is AI based technique? You all know, because artificial intelligence, you know that before to understand artificial intelligence, one has to know the attributes of what is an intelligence. Intelligent system is that which can observe. A human being is the best example. It can observe, it can think, it can react, it can connect, it can compare. These are the attributes of an intelligent system. And depending on how fast it does, the more is the intelligence of the human being, more is the intelligent power or IQ of the human being. Now, people thought if these attributes could be inbuilt in a system, in a hardware, rather a system, that can also behave like, to some extent, an instrumentation, because otherwise it is a black box. It is just nothing. You give some input, and by default it will give you some output. You have a controller, you have the desired output, all right. But accordingly, if you can think, if you can observe, if you can compare, if you can collect, and accordingly work, that becomes an intelligent system. So artificially, there are certain methods like neural network, artificial neural network, fuzzy logic, neurofuzzy, etc. So many methods are there which were tried. Heuristic methods were tried, and they were inbuilt. Some intelligence was inbuilt in the machines, in the system itself, and that became the artificial intelligence system. So the techniques which are AI based are known as AI based techniques. The second one is machine learning techniques. The machine will one stage ahead of what is that artificial intelligence. It is definitely an artificial intelligence system, but it is slightly ahead. It is an advanced version of that, and it can learn. The machine can learn. Otherwise, what is happening? If you have a system, you have to program it. The user is the master, and the way you program it, the way you feed your software in it, it will work. If you make some mistakes, it will not be able to rectify the mistake. It will accordingly work, and error will take place. The output will again not be desired one. So now machine learning techniques have little bit of learning of the machine by itself. That is known as machine learning techniques. And further, the most advanced stage is the deep learning techniques, where the machine almost behaves like a human being. Let us see in detail on these. Next slide, please. So that is what I was talking about. The whole domain is artificial intelligence. As I explained you, any technique that enables computers to mimic human intelligence using logic, if-then rules, decision trees, and machine learning, including deep learning, is known as artificial intelligence technique. So it is the big umbrella. It is the total domain. We call it artificial intelligence, and we have artificially inbuilt certain attributes of an intelligent system to make it work like an intelligent system, and that's why we say artificial intelligence. Now, in this same domain, further, as I explained you in the last slide also, the next ahead state of artificial intelligence was machine learning. It is a subset of that, includes attributes, aptitude statistical techniques that enable machines to improve tasks with experiences. The category include deep learning also, because deep learning is a subset of this. Now let us come to the deep learning. The subset of machine learning composed of algorithms that permit software to train itself to perform tasks like speech, then image recognition, then exposing multi-layered neural networks to vast amount of data, etc. So I would like to explain you a little more in deep learning, because the deep learning is also a kind of deep neural network also they call it, and deep network also they call it. It is a kind of subset of machine learning, which itself can learn many things without any supervision from the human being. It does not require any human to human or human to machine interface. What has happened is the people have developed certain neural networks, deep neural networks inside, which can learn itself by changing its modes, its weights, etc. Because I'm not going in detail about the neural networks of weights, etc., hidden layer and input layer and output layer, but it can change. The neural network is framed in such a way that it can change those nodes, it can change those weights, etc., to behave just like a human brain. So in other words, we can say that deep learning is nothing but a kind of function, AI function, which imitates the working of a human brain to understand and to get the work done, to operate in the work done, to be done for taking decisions, useful decisions, which is perhaps very less in machine learning and which is absolutely less in artificial intelligence. The decision which an artificial intelligent device can take is very limited. Further is the machine learning and further is the deep learning. The deep learning is also, I would like to give an example here. The spiritual gurus, वो क्या बोलते हैं? वो बोलते हैं, मैं हिंदी में थोड़ा बोलता हूँ आपको, जो हमारे स्पिरिचुअल पंडित से गुरुज हैं, वो आपको कहते हैं कि जो आत्मा है, आत्मा, मैं उसको एनर्जी के साथ रिलेट करता हूँ एज अ साइंटिस्ट और एन इंजीनियर. तो आत्मा वर्सेस एनर्जी, वो उसको आत्मा बोलते हैं, मैं उसको एनर्जी बोलता हूँ. वो कहते हैं आत्मा की 3 शक्तियां होती है, मन, बुद्धि और संस्कार. I say मन is nothing but mind, buddhi is nothing but intelligence, and sanskar is nothing but the experience. That means the past data what you have got in your data storage. अब देखिए, जब डीप लर्निंग में वो कहते हैं कि आत्मा जब खत्म हो जाती है तो जो शरीर है वो निर्जीव बन जाता है. Same here in the science also, if you try to relate, when the machine is de-energized, it becomes a dead machine. If there is no energy, it cannot think, it cannot work, it cannot do anything. So it is a dead unit. Now inside also, if we have something like mind, matlab buddhi, and we can something have a data storage, so it can also work as a human being. That is why it is known as deep learning. क्योंकि इसकी जो neural network होती है वो अपने आप में कुछ human जो biological neural network है उस जैसा ही trace किया है. It is almost like a biological neural network, and that is why it is known as deep learning. And nowadays, lot of research is taking place, and money laundering, then machineries, and then productions, and then fraud cases, every field we have the application of deep learning. So this is very, very important. And another example here is, this is any technique which enables computer to mimic like a human behavior is artificial intelligence. It was, the years have been shown here, from 1950s till 1980s, we were in the same domain. Then little higher stage of the same domain came, which is the machine learning, AI technique that give computers the ability to learn without being explicitly programmed to do so. And finally, it is the deep learning, where it is a subset of ML, machine learning, which makes the computation of multi-layer neural networks feasible. Multi-layer neural network, as we say in the multi-layer, there's a hidden layer, input layer, and etc., output layer. It is a multi-layered input neural network which can take decisions like a human. Next, please. Next slide. Yeah, same example, another example, artificial intelligence. From this year to about 90s, 80s, we had AI, then we have machine learning, and further we have deep learning techniques. So deep learning is more regarding the brains. You see, it is more brain operated. So human being brain is almost done in the machine, and that becomes the deep learning. Next, please. So if you see what is a traditional machine learning, suppose the input is a dog, barking dog, then feature extraction will take place, which has been spoken by him, or he has barked something, the features are there, extraction will take place, and classification, these are the stages, classification will take place, and finally the output there, whether it is a dog or not. But deep learning, you have same input, output, not dog, dog or not dog, but all these steps are being done in the deep learning process. It is one process which is done by itself. So there is no supervision here. Without supervising from the human being, it can take up. The machine almost work like a human being. Next, please. So data mining and big data are very, very important topics these days, because anything what you want to do, as I said, experience, it is the information. The experience is nothing but the information, and that is in the form of data. So there are so many data, big data that we call it, big data. It is an ocean of data. So data analysis, analytics, data mining, and big data analytics, software tools, machine learning, and methods and algorithms. So what are you doing? The storage where the data is kept is known as big data. It has got so many data. It could be mechanical data, computer data, it can be electrical, it could be machine, it could be medical, it could be engineering, it could be physics, chemistry, anything. So that is an ocean, and we call it big data. But big data may not be useful for a particular task. For a particular task, you have to be with those data which is relevant. So there comes the role of data mining. So data mining is that process of, it is an AI function again, which takes out the data, it filters the data from the big data, and it becomes a useful data or a relevant data and meant for a particular task. So this is these days very much used, and all these are softwares. Data mining, big data analysis is through softwares. Of course, the big data is kept somewhere. It could be a cloud, it could be a big server, it could be a supercomputer, but from there it is to be accessed. The data has to be accessed, and from there the mining has to take place. Mining will guide you what kind of data you need for your particular task. So data mining is very, very important. Big data is the storage. Next, please. So various machine learning algorithms which are used for research also. I am sure many researchers are sitting here, so it is a very useful information for you. The decision tree, the ensemble classifiers, the KNN classifiers, and the SVM classifiers. Next, please. Next slide. Here I am going to give you two examples, two case studies taken up by two of my PhD scholars. One was the one which was taken, it is already awarded. It was done by Dr. Rammurat Singh, and he did it for robotics or exoskeleton robots, and he took out the surface EMG signals, and those signals were acquired, and after that they were classified and classified for different movements of the hand movement, and those were taken up for the exoskeleton robot. That was done by Dr. Rammurat Singh. It was a very good job, and the classification accuracy for different classifiers I have shown. It is his work. The first one is the decision tree, and you see that the complex tree, medium tree, and simple tree, we have shown the simple tree has the minimum efficiency, that is accuracy, that is about more than 91%, and the medium and the complex trees are almost same. They are more than 92.3% or something like that. Next, please. Next. Yeah. Another classification accuracy that was for ensemble classifier. Here, boosted tree, then beg tree, then sequence discriminant, and subspace KNN, and RUS. These are the different classifiers, and here also you can see that different accuracies were obtained for the different classifiers, and the maximum was obtained as about 96% or so, 95 to 96%. Next. Again, a classification accuracy for KNN classifier. Here, 5 classifiers were there: fine KNN, medium KNN, coarse KNN, cosine KNN, cubic KNN, and weighted KNN. The maximum accuracy was found in the fine KNN, which was about 95.8% or so. That was the accuracy found. Next. Next, please. Yeah. Another was the SVM classifiers. Here also different SVMs were tried: the linear SVM, the quadratic SVM, the cubic SVM, the fine Gaussian SVM, and the medium Gaussian SVM, and the coarse Gaussian SVM. The maximum accuracy was found in case of the cubic SVM, and that was about 95% accuracy was obtained. So next slide, please. Yeah. So you can find out from the earlier slide that different classifiers were tried, and some of them got accuracies very high, and the maximum accuracy was obtained about 96%, 95.7, 95.8. The second case study is about the condition monitoring for predictive maintenance of induction motors. This was taken up by another PhD scholar of mine. He is Mr. Amandeep Sharma. He has submitted his PhD and his thesis is pending. So I cannot share the data from his work, but this was the performance analysis of a surface EMG based control scheme for this induction motors. So what he does, it was a fault monitoring system, fault monitoring diagnosis. So induction motors, if you see, they are the backbone of modern industrial processes due to their reliability and robustness. Sometimes these motors are operated under overloading and environmental stresses such as high ambient temperature, high moisture, etc., leading to their unexpected failures. Because of this high temperature and high moisture content, the overloading takes place, and this unexpected failures take place. So this is inductive motor faults are mainly electrical faults and mechanical faults. The motor faults, the stator faults, electrical faults have the stator faults, the rotor faults, and the mechanical faults have a bearing, gearbox, and torque oscillations, and air gap eccentricity. These are the faults which normally come in across in the running of induction motors. Next, please. Next slide. Yeah. Now, earlier it was predictive maintenance. The maintenance strategies have progressed from breakdown maintenance to predictive maintenance, then to condition-based maintenance, which is called CBM, and lately towards a futuristic view intelligent predictive maintenance system. You see, earlier we had this maintenance strategy, the breakdown maintenance. Whenever the machine gets broken down, we will start maintaining it. That was the old practice, but now it is all over. Preventive maintenance is there, and condition-based maintenance, CBM, is also there. Preventive maintenance is that you have to do it in other than the routine maintenance, so that the breakdown doesn't take place, and before the breakdown it gives you certain signal, and you come to know that the breakdown may take place if it is not done properly, maintenance is not done properly. Then condition-based maintenance, CBM, has taken place, and now these days the predictive maintenance system means you have to futuristic, you have to predict the maintenance, and intelligence systems are used for that. For that, you are using this machine learning techniques, etc. Predictive maintenance can reduce preventive maintenance and has overall positive effect in terms of reduced downtime, additional productivity, and requirement of less maintenance costs. It's quite obvious. If you can predict by applying these intelligent machine learning techniques that how you have to maintain it for future, say for another year or 6 months or so the life can be saved, the downtime can be reduced, and additional productivity can be achieved. Less maintenance, obviously, for the cost will take place. Next slide, please. Yeah. So industrial maintenance strategies, you have reactive run to failure. This is havoc sort of thing, and when you are react and run to failure and you don't do anything and the havoc has taken place and the damage has already been done. So active and reactive is this. And what is active? We have to be preventive and predictive in nature. So the machine stays as it is, the production stays as it is, and you are progressing. Next slide. Next slide, please. Fault diagnostic methods for induction motors. Many diagnostic methods have been developed so far, such as electromagnetic field monitoring, axial flux monitoring, temperature measurement, which is known as thermography, vibration monitoring, acoustic noise measurement, partial discharge analysis, and chemical analysis. But these days, in this thesis, motor current signature analysis, MCCA, and artificial intelligence and model-based artificial intelligence and machine learning, ANN, KNN, SVM, etc. These are the machine learning techniques. These techniques have been used. Next, please. So, condition monitoring and fault diagnosis. Condition monitoring is referred as a process of monitoring the specific parameters of motor like vibration, voltage, current, temperature to detect early signs of failure and or to estimate the machine's health and forecast the need of maintenance beforehand. So motor under test will go signal acquisition, then it will have pre-processing, then have feature extraction, then fault detection, and finally the maintenance. And for that, intelligent systems, intelligent algorithms are being used. Next slide, please. This is an outline condition of a monitoring strategy. Suppose I have taken an example of 3-phase 50 Hz induction motor. So the input is given. So what we are taking, we are taking the signatures, the voltage, current, monitoring, and then finally it goes to computer. What goes? The voltage signal goes to the computer, and the current signature also monitored and goes to the computer. Of course, this side is the accelerometer. Accelerometer also gives the vibration, and that is also monitored and given to the computer. So these becomes the basic parameters: the voltage signature, the current signature, and the vibrations. And on that, those three parameters, the analysis is done. Next, please. Next. Yeah. Machine learning based analysis. So this is active acquired data, then process data, identify condition induction in indicators, train the model, and deploy and integrate. The signal-based condition indicators features are time domain features, frequency domain features, time frequency domain features. Of course, here in time domain features, we have mean, standard deviations, skewness, root mean square, and kurtosis, etc. These are the features. And frequency domain, power bandwidth, frequency bandwidth, peak values, peak frequencies, harmonics, etc. And in case of time frequency domain, we have special entropy, special kurtosis, etc. Now here, the mathematical model when you use for analysis, here it is very clear that in time domain, you use mostly the Fourier transform and the other transforms, Z transforms, etc. In frequency domain, of course, Fourier and Z transforms are used. Laplace transform can be used in time domain. And in time frequency domain, to analyze the features, we have to use the wavelet transforms, because wavelets are those which are time changing as well as frequency changing. And you have to finally use this convert it from time domain to frequency domain, and because anything which is to be solved through mathematical equations, the frequency domain becomes much easier to solve, because in writing differential equations in time domain, it becomes very huge, and the solutions sometimes are not obtained. So that's why we go from time domain to frequency domain. But there is another domain called time frequency domain, where you cannot perhaps use the frequency, the Fourier transforms, etc. You have to go for wavelet transforms. Next, please. Yeah, condition monitoring application areas. These are the areas: rolling mills, tool machines, sealers, compressors, power generations, oil and gas, marine, mines, transportation, aerospace. There are many more. Next, please. Next. So software tools used. Software tools are Java, Python, Hadoop, MATLAB, and R programming. R programming is very vastly used these days in industrials, and Hadoop is used for your data mining, etc. Python, as you all know, Java, etc. These are the software tools which we use for analysis. Next, mathematical tools, I have already told you, the Laplace transform, the Fourier transform, the Z transform, and the wavelet transform. And the need is that why do you change from time domain to frequency domain is clear to you. And next is the Internet of Things. As you know, Internet of Things, it is the talk of the day. Anything, any device, anyone, anybody, any service, any business, any path, any network, any place, anywhere, and anytime, any context. So this is in nutshell what is Internet. Internet is the complete application of all the computers connected in a system. The power of the computer, the frequency of the computer, the speed of the computer, the platform of the computer can be used without actually having that supercomputer or whatever it is. This is in nutshell the Internet of Things, IoT. Next, please. This is the application of IoT, the transport logistics, utilities, smart cities, smart building, consumers, industrials, environment, agriculture. There are many more sectors because IoT is nowadays used in almost all sectors. Next. This is IoT-based greenhouse automation. I have shown you. The cloud has the data. It goes to the connection gateway, which can be smartphone, can be used to remote control, and you have the monitor display, and finally it goes to the house where you have the sensors and actuators, controllers and switchgear, and on off of all your illumination, fans, ACs, etc. can be done. So this is one example I have given for the greenhouse automation using IoT. Next, this is cloud computing applications. As you all know, cloud is nothing but the storage. It has house the maximum data available in any form, application, platform, infrastructure. We have all kinds of content, communication, finance, database, cube, network, block storage, computer, etc., etc. And it can be accessed by your servers, laptops, desktops, tablets, phones, etc. So cloud computing applications are very much there. It is nothing but a kind of amalgamation of all kinds of data housed in one catchment area that works as a house for you. Next, please. Next. Yeah. Finally, the grid computing application. It is a grid. It is the structure where, because you may not have all the things at your disposal, but grid resource management system is there, which has connected all the things. Means resources, like all resources are there, all systems are there, users are there, and resources and users are connected to a grid, which is known as the computing grid and known as the grid computing. And I can use any platform, the application of all the computers, the total power, the total storage, etc., etc., by sitting at one place. So these days, grid computing is a very big tool along with cloud computing for solving all sorts of problems. Next, please. Next. So that is all I wanted to discuss with you. And I would like to thank you very much for a very patient hearing. And again, with these words, I would like to thank the organizers. All the organizers were directly or indirectly connected to this event. It is a fantastic event, and I sincerely hope great success to this. Thank you very much. Thank you. Question and answer session.
Dear participants, if you have any question, then you can ask to sir. Sir has explained each and everything in an efficient way, but if you have any question, then you can ask.
Thank you, sir, for giving us such a very good lecture. I am Rakesh Kaplial from NIT Uttarakhand. and I'm the research scholar in electrical engineering department from NIT Uttarakhand.
Okay.
Sir, I have a question. Sir, what are the scope for conditioning monitoring of power electronics based devices?
Yeah. There is lot of scope of conditioning monitoring in case of power electronic devices, because the power electronic devices are nowadays used for conditioning monitoring of the big machines used in the industries, and there a lot of application of this thing is there, and conditioning monitoring will give you the health of the machine, the motor, and the drive actually. So their conditioning monitoring is a very useful tool.
Thank you, sir. One more question, that on which parameter majorly we can focus monitoring of these devices for power electronics based?
Well, power electronic devices, if you say, you have harmonics. One is harmonics.
Yes.
The other is the voltage fluctuations, which cause frequency also. Frequency fluctuation, voltage fluctuation, harmonic content, etc. And then the machine which is being driven, that drive actually, the drive has to be incorporated with the, whether it is well incorporated with the controller, that is our electronic controller. No. Here the machine conditioning has to be done.
Okay, sir. Thank you, sir.
Thank you.
Any more question from the participants? If any participant having any question, then he or she can ask. Sir, presentation was very interesting and useful, and I have seen our maximum final year BTech students enjoyed the session. They want to understand on which side we can prepare for their final year project. So you have discussed here machine learning and industry 4.0 and condition monitoring. So if any BTech student want to make project, so in the recent technology, on which side he or she should be concentrate to make a effective project?
Yeah, the very relevant question. I think for the students, if they work on the machine learning process, machine learning is one very, very important area wherein he or she can use the different classifiers. Now, this can also be done for picture image processing. It can also be done for language translation. It can also be done for, as I said, health monitoring machines. So machine learning process is one which is a very important tool to be used by the researchers, especially at the BE level. And they can also go, for masters and all, or PhD, people can go for deep learning techniques also.
Okay, thank you so much, sir. If any participant is having any more question, then he is invited. Because we have to conclude the session and we have exceeded the time already. But in spite of this, if you have any question, then you can ask.
नमस्ते सर। सर मेरा नाम नसरुल्ला है। सर मैं एक क्वेश्चन पूछना चाहता हूँ कि हम लोग अभी प्रोजेक्ट बना रहे हैं, फाइनल ईयर में है, फॉल्ट डिटेक्शन पे। तो इनिशियली हमें क्या क्या चीजें रिक्वायर्ड है कि जो प्रोजेक्ट को कंप्लीट करने के लिए, या
क्या चीज बना रहे हैं? मैं सुन नहीं पाया आपको, क्या चीज बना रहे हैं?
सर हम लोग एक प्रोजेक्ट बना रहे हैं फॉल्ट डिटेक्शन पे।
अच्छा, फॉल्ट डिटेक्शन व्हाट, किस चीज का फॉल्ट डिटेक्शन कर रहे हैं?
सर
ट्रांसमिशन लाइन का। अच्छा
सर, इनिशियली तो हम लोग को क्या क्या चीजें, मतलब सारे जो पॉइंट्स है, क्या चीजें साथ में लेके चलना चाहिए ताकि जो हमारा प्रोजेक्ट हो सक्सेसफुल प्रोजेक्ट हो?
एक तो सबसे पहले आपको ट्रांसमिशन लाइन की जो कैपेसिटी है वो पता होनी चाहिए। कैपेसिटी इन द सेंस कितने पावर लाइन है वो, उसकी वोल्टेज रेटिंग कितनी है, उसकी करंट कैरिंग कैपेसिटी कितनी है, उसके अंदर कितनी आपकी इंफ्रास्ट्रक्चर बिल्ट है और कितनी केबलिंग की लाइन है। ये सबसे पहले आपको पता होनी चाहिए। दूसरी चीज आपको ये पता होनी चाहिए कि कितने डिस्टेंस तक वो लाइन फीड कर रहा है, आपका कहाँ से कहाँ जा रहा है, 400 किलोमीटर का है, 1000 किलोमीटर का है ये। उसके बाद आपको ये पता होना चाहिए कि इनमें नॉर्मली जो लॉसेस होते हैं, ट्रांसमिशन लॉसेस, वो होते हैं फॉल्ट्स की वजह से। जब फॉल्ट्स होता है अगर आपका लाइन ठीक ठाक चल रहा है तब तो उसके अंदर, चूंकि वो जो जिसको बोलते हैं ना कटिया लगाना, वो पॉसिबल नहीं है। डिस्ट्रीब्यूशन लाइन में तो लग जाएगा, लेकिन ट्रांसमिशन लाइन में कटिया संभव नहीं है। अदरवाइज इसके अंदर चोरी की संभावना कम होती है, डिस्ट्रीब्यूशन लाइन में चोरी की संभावना ज्यादा है। इसलिए उसके अंदर जो फॉल्ट होगी, उस फॉल्ट को आपको एनालिसिस करना पड़ेगा। अगर वो 3 फेज शॉर्ट सर्किट फॉल्ट है, सीवियर फॉल्ट है, फिर आपको ट्रांजिएंट पॉइंट ऑफ व्यू से देखना पड़ेगा, वह स्टेडी स्टेट ट्रांजिएंट है या ट्रांजिएंट फॉल्ट है, क्या किस टाइप का फॉल्ट है, वो देखना पड़ेगा। उसको स्टेडी स्टेट लाने के लिए फिर आपको उसकी ब्रेक लगानी पड़ेगी, मतलब कंट्रोलर यूज करना पड़ेगा। वो कौन सा कंट्रोलर आप यूज करेंगे, इसकी भी जानकारी होनी चाहिए। और फिर आपको बीच बीच में उनकी वोल्टेज रेटिंग, करंट रेटिंग सारा नापना पड़ेगा कि फ्लक्चुएशंस कितना हो रहा है। अगर फ्लक्चुएशंस हो रहा है इन टर्म्स ऑफ व्हाट, कहां पर हो रहा है, फिर आपको एनालिसिस करना पड़ेगा कि वो किस कारण हो, क्या हार्मोनिक्स की वजह से है, क्या पावर फैक्टर की वजह से है, किस कारण से वो हो रहा है। तो दीज आर द पैरामीटर्स ऑन विच यू हैव टू वर्क इन डिटेल।
Thank you, sir. Thank you.
Thank you so much, sir. If you have any more question, if any participant is having any more question, he is okay. I think all questions have been discussed by honorable speaker. So Shrikant, please you can proceed now. We have to conclude the session. Yes, Shrikant, please.
Thank you, Dr. Chatterjee, for this excellent presentation. Your talk provided our audience great knowledge in the continuously developing field of machine learning, AI, and IoT. I'm sure with the doubts resolved, they are bound to achieve great heights. Now I request the event coordinator, Dr. Khadim Moin Siddiqui, to present the vote of thanks.
Thank you so much, Agatha Singh. I am here for vote of thanks. Very good afternoon, Honorable Speaker, Professor S. Chatterjee, retired professor and IEEE Chandigarh, Honorable Director BBDITM Professor Dr. Bhavesh Kumar Chauhan, respected HOD ENDN Professor Rafiq Ahmad, Dr. Parthish Paul, Branch Counselor ADG ITM Delhi, faculty participants, student participants, and volunteers. It's my proud privilege to propose vote of thanks on the 4th day of 7-day event, IEEE Virtual Boot Camp under IEEE R10 SEC Membership Development and Leadership Training. Today, informative and splendid lecture has been delivered by none other than a great personality, professional, educator, counselor, and working for humanity since a long time. Yes, today's speaker, Honorable Professor S. Chatterjee, retired professor NI TTTR Chandigarh, topic on buzzwords on automation. I take this opportunity to express our profuse gratitude and sincere thanks to Honorable Speaker Professor S. Chatterjee for guiding us in this event. Sir, you have enlightened us on the fabulous topic, and we have learned a lot. Today, we have seen a large number of researchers and final year students have joined here because they want to understand buzzwords in automation and in recent trends. So thank you very much, sir. You have explored here for your valuable time, and you have given us your previous time. We are very much thankful to you, sir. I take this opportunity to express our sincere thanks and deep gratitude to Professor Dr. Bhavesh Kumar Chauhan, Honorable Director BBDITM Lucknow, for his esteemed presence amongst us and for presiding over the event. The valuable thoughts that he has expressed on this occasion will no doubt are help us. Thank you so much, sir, for your encouraging words. Further, I would like to thanks to our respected HOD, Professor Rafiq Ahmed, for his suggestions and support. Sir, without your constructive suggestions, we cannot organize this kind of program in the effective way. Thank you so much, sir. I extend my thanks to IEEE Student Branch, ADGITM Delhi, led by their branch counselor, Dr. Parthish Paul, for their support. Now, thanks to all participants for joining us and making the event successful. At last, thanks IEEE BBDITM student members, especially Srikant Singh, Marut Nandan Tripathi, Shivali Prasad, Avinash Gupta, Sakshi Priyam, and the anchor Agrita Singh for your dedication of smooth conduction of the program. Again, thank you so much all.
Thank you, Khadim Saab. Thank you very much.
थैंक यू सो मच सर, आपने हम लोगों का इनविटेशन एक्सेप्ट किया और एक बहुत यूजफुल टॉपिक पर आपने प्रेजेंटेशन दिया और आज बहुत सारे स्टूडेंट्स कनेक्ट हुए समझने के लिए कि मतलब हम लोग कैसे प्रिपरेशन करते हैं. थैंक यू वेरी मच सर फॉर योर अगेन थैंक यू सो मच फॉर योर वैल्यूएबल टाइम. जी सर. जी सर. श्रीकांत, नाउ वी कैन लेफ्ट फ्रॉम द मीटिंग. श्रीकांत.
Thank you, sir. Now
Yes,
for the past participants, the details about the assignment.
Agrita, now we can Agrita, now we can left the meeting.
Yes, sir.
Okay. Thank you so much. Okay. Thank you.
For the participants, the assignment links will be mentioned in the chat box. I would like to emphasize that today's case study is only for students. The quiz can be attended by all participants. Please visit our website to find all the details and instructions. The link for the assignment will soon be made available in the chat section. This brings us to the end of day 4.
Hello.
Hope you all had a good time.
Hello.
Tomorrow we meet with the same
Very good. Thank you.
as we dive into the life of a very prominent woman in technology and the contributions to the field. Visit our website for any and